Hello everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज हम लोग कंप्यूटर नेटवर्क की क्लास करने वाले हैं जो कि आपका क्लास नंबर 9 है. ऑलरेडी हमने 8 क्लासेस कर लिया है कंप्यूटर नेटवर्क का. तो फर्स्ट ऑफ ऑल इट्स अ ह्यूज रिक्वेस्ट फ्रॉम माय साइड to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the class 9 we will discuss unit 3rd network layer, and hopefully in this class we will be ending with network layer unit 3rd, and in the next coming class we'll start with unit 4 as well. So in the last class we have discussed about the multiple network, and that is your subnet mask code and or subnet mask format. Now today we'll do a question, starting with a question here, that is that answer each question like how does the Earthnet address, that is IA, and that is your 3B, 4C, 6D, 2E and 1F appears on the line binary, and explain, define and explain the types of the following destination address, that is your F, that is have to be you have to define it out. So let's go ahead and solve one by one. So the first part of the question is that answer each question that is named as, and this is your unit 3rd, that is your network layer. Okay, so we had completed unit 1, and that is your introduction to computer network, and the unit 2, that is medium access sublayer. Now we'll start with the network layer here. So the first part we have to solve it, that is how does the Earthnet address 1A, that 3B, 4C, 6D, 2E and 1F appear on the line binary. Explain. This has been asked of 10 marks. This is of 5 marks, and the other part is of also 5 marks. So first we'll solve this. The Earthnet addresses that we have here, that is the solution. The Earthnet address is 1A, 3B, 4C, 6D, 2E and 1F. The binary for that, this is an Ethernet addresses, and for the binary of it, that we have 0001, 1010, 0011, 1011, that then we have again that is your 0100, 1100, then 0110, 1101, then of course 0010, 110, and then again we have 0001 and 111 and 1. The address is sent left to right, byte by byte, and for each byte it is sent right to left, bit by bit, and we interpret each 4-bit pattern and has an hexadecimal digit. So we then group the hexadecimal digit with the that is your colon, and between the pairs of the pairs we have is your, that is your 5A, 11, 55, 18, AA and 0F. So that is the representation of with the colon that we had represented here. So the second one we have in here only, that has been asked, that is the second part, and that has been asked, and that is your, we have explain, and that is define, and explain the types of the following destination address, that is ff, then again ff, ff, then again ff, then again ff, and then again ff. This has been asked of 5 marks, and this also has been asked of 5 marks. So total they had asked you about 10 marks. So for this we have a solution here. For the here, that is to find the type of an address, we need to look at the second hexadecimal digit from the left, and it is even the address in the unicast, and if it is not, then the address is multicast, and if all the digits are f's, so the address is that is your broadcast. So this is a broadcast address because all the digit is f, so this is known as broadcast. The address is broadcast here. Okay, so that is your broadcast. Otherwise, if it is even, then the address is unicast. If it is odd, then the address is multicast. If all the digit is f, so that is means that the address is broadcast. Okay, so now we'll go ahead with the another one, that the broadcast address, you have to write it on address as well. So the next they had asked you about 10 marks in many time in the examination paper as well, that find the class of each address. Find the class of each address. The first we have here is, that is for 140.213.10.80. So the first 4 bit of the address determine the class to which the address belonged and specified how the remainder of the address was divided into the prefix and suffix as well. For this, that is 140.213.10.80. Here the given IP address is of class B address. Okay, this is of class B address. Okay, in the same case of the class B address here, that we'll talk about, with the same case, if we go ahead, we have to know which class they are belong to. So for that, that in the class B network, the first 2 bits are assigned in the network address, and the remaining 2 bits bytes are, that is used for the node address. So the format is that where, that is your network dot node, and for the representation of this we have, that is here, this is class B, this is 10, this is network ID, host ID, and then we have here, that is of class B, one 128.0.0.0. This is from 1 this one is your net ID, and this is the another remaining one is your host ID. And for here 191.255, this is net ID, then 255.255, this is your host ID. Okay, so now we'll go this is okay, this is your host ID. Now let's go ahead with the another one, and for that the second part we have to solve it, and that is we have, that is 52.15.150.11, that has also been asked. And here that the given IP address is class A, तो ये जो belong करता है वो class A को belong कर रहा है. Okay, so the representation we have here for the class A, this is class A, which is 0, net ID, this is host ID, where in the same case this is class A, this is 0.00.0. This 0 here that is your network ID, that is net ID, and for this the remaining one is your host ID. And for the another one we have here that is 127.255.255.255. So 127 is your net ID, that is your network ID, and this is host ID. Okay, so here in the class B network, the first 2 bytes are assigned in the network and address, and the remaining network bytes are used for the node address, and that the format is network.network.node.node. Okay, that is the representation. Now we'll discuss about the another question, that is your what is the type of the following addresses. That has also been asked of 10 marks and 5 marks in different examination paper. So for that we'll do it, बिकॉज इस टाइप के क्वेश्चंस बहुत पूछे जाते हैं आपके क्वेश्चन पेपर में. सो दैट इज़ द रीज़न आई विल मेक यू प्रैक्टिस दैट. व्हाट इज़ द टाइप of the following addresses. The first we have 4F A234 2. So for that here that IPv6 addresses are of 128 bits in length, and addresses are assigned individual interface on the nodes and not to the node themselves as well. And for that single interfaces may have multiple unique unicast addresses, and the first field of any IPv6 addresses is variable length format prefix and identifies the various categories of the addresses as well. And a new notation has been devised for the writing 16-bit addresses, and they are written as 8 groups of the 4 hexadecimal digit with a colon, and that is between like 8000 and 00000000123 4 5 6 7 or 8 9 AB or C D E F as well. That is leading terms with the within that the group of that is omitted, and 0 1 2 3 that can be written 1 2 3 as well, and one or more groups of the 16 zeros bits that is replaced by the pair of the colons, and the addresses new becomes as like 8000, then double columns and 1 2 3 4 5 6 8 9 AB and C D E F. With these, that the first field of any IPv6 addresses is variable length, that is the prefix, and which satisfies the various which even though identifies the various categories of the address, where the IPv6 allows 3 types of addresses. The first is unicast, anycast, and multicast. In the unicast, an identifier for a single interface; anycast, an identifier for a set of interfaces; and for multicast, an identifier for a set of interfaces, and a packet sent to a multicast address is delivered to all interfaces identify that address. So here we'll have a 4F that is your A2 that is 34 colon 2. This given IPv6 addresses is provided based on unicast. That is IPv6 address that has been provider based unicast address. So for the next one we have is your 52F 1 2 3 4 2 2 2 and 2 as well. The given IPv6 addresses is unassigned. Is unassigned here. Okay, so this is the representation. Now we'll discuss about moreover related to the another question, that what are the networks numbers, subnet numbers, and host numbers for the addresses 135.104.192.100. So that we have to deal with a detail here. So that we'll discuss, and we have to form our network addresses as well as subnet addresses, even though the host numbers that we have to discuss here. So let's go ahead with that. So here we'll have another question here, and that is what are network number, subnet number, and host number for address 135.104.192.100, and the mask is 255.255.128.0. So this has also been asked of 10 marks, so we'll go ahead with the solution. And this is that the given IP address is your 135.1404192.100 here, and that is a class B addresses, and in that class B network, the first 2 bytes are assigned to a network addresses and the remaining 2 bytes are for the node addresses. So the format of class B that we have is network dot network dot node, and in the it takes the first 16-bit as a network number, so that the network number is your 135.104. Okay, this is the network number here, because the second 2 bits we conclude as network here. And in the same case, to find the subnet address, that the methods are used, this is the network number here 135.104, and in the same case there are the boundary level masking for the non-boundary level masking. In a boundary level masking, the 2 masking numbers are considered as 0 or 255, and with the same reference in the non-boundary level, the masking or the value of the masking is used apart from 0 and 255, where if the mask number is 255 in the mask IP address, then the IP address is repeated in the subnetwork address as well. With the same case, that is, if the mask number is 0, then in the mask IP address, then 0 is the repeated in subnetwork addresses as well. Where for any other mask number, that is bitwise and operator is used, and a bitwise and ing that is done between the mask number byte and IP addresses in the form of the byte as well. With the same case, for the subnet number, we will calculate that. We have 135.104.192.100, and for here that is 255.255.128.0, and for that we will be going ahead, so we'll get here 135.104.128. so this will get here, and this is for the subnet number. And for since 128 is a bit in a 100, that a 128 bit 1000000 and 0, and for the 192 we have 11000000, and only 1 is a bit that is used for the subnet, so the subnet ID is 128 here. And with the same case here, the ID is last 8 bit, so that is your 100. Okay, so with the same case, now we'll discuss the another point that is in the terms of it, and that we have is your what is IP addressing and how it is classified and how is subnet addressing is performed. That what we have to discuss. So let's go ahead. IP addressing. In IP addressing here, that is your how it is classified and the how subnet addresses is performed. That has also been asked of 10 marks. So let's go ahead with IP addressing here. In the same case, the IP corresponds to the network layer in the OSI reference model, and that provides the connectionless best effort delivery, that is service to the that is transport layer, and an internet protocol address has a fixed length of 32 bits, and where the address structure was originally defined to have a 2-level hierarchy, that is your network ID and a host ID, and the network ID identifies the network and the host ID is connected to, and the host ID identifies the network connection to the host rather than the actual host as well. In the same case, that the IP address structure is divided into the 5 addresses class, that is of class A, class B, class C, class D, and class E, that is identified the most significant bits of the addresses. where the class D addresses is used for the multicast services and to allow to send information to the group of the host simultaneously, and the class E addresses are reserved for the future use as well. With the same case, if I'm talking about with this, so that the class A addresses were designed for the large organization with the large number of the attached that is host or the routers as well that has been used. And for the class B addresses were the design for the mid-size organization with that that the tens of thousands or attached host and the routers we have. For the class A and the class B, in a class network, that the first byte is assigned to the network addresses, and the remaining the 3 byte is used for the node addresses, and that the class format is network dot node here. For the class B network, the first 2 bytes are assigned to the network addresses and the remaining bytes are used for node addresses, so that the format we have for the class B is that network.node.node here. In the class C, same, that the network, the first 3 bytes are assigned to the network addresses and only 1 byte is used for the node addresses here. So that is that the format is network.node here. In the same case, that to allow a single network addresses to span multiple physical network is called a subnet addressing or a subnet routing or a subnetting. That the subnetting is required part of an IP addresses here. To understand the subnet addressing, consider the next example, like considering the site has a single class B IP network addresses that is assigned to it, but the organization has 2 or more physical networks, and only the local routers know that there are multiple physical network and how to route traffic among them as well. In the same case, in an example, the organization is using the single class B network addresses for the 2 networks, and for the subnet addresses scheme to work, every machines on the network must know which part of the host addresses will be used as a subnet addresses, and this is accomplishing by assigning a machine a subnet mask as well. Let's go ahead with the question that we have to do it, that divide the network 220.125.5.192/26 into 8 subnet, and how many hosts that can be connected to each network, and show their IP ranges, network addresses and broadcast network as well. So let's go ahead. Divide the network 220.125.192/26 into 8 subnetwork. How many hosts can be connected in each network? Show their IP range, network address and broadcast address as well. So now we'll go ahead with the solution. So here in the solution, that what we have to do it, and in the same case the solution is that is n equals to 2 to the power 32 minus 26 that we had been given it here in the form of slash. So that is equals to 2 to the power 6, which is equals to 64 here. And the first address in the network we have, that is first address in network, that is we have 220.125.2.192/26. the last address in network we have 220.125.5.255/26. So we required 8 subnet, so 64 oblique 8 we have, and that is in the same case you will get 8, and so every network contain 8 address here, and for the 8 network and 3 bits are required to add 26 masks, so that new mask will be 26 plus 3, that is 29. So subnet 1 we have, and for the broadcast address subnet network 2, then broadcast network subnet network 3, then sub broadcast number, and then we have subnet network 8, and for the broadcast addresses as well. So that we'll discuss here in the detail as well, so we'll just go ahead to write it down. Here we have first, that is subnetwork 1. So here that is 220.125.5.91922, 220.125.5.199. Then for the broadcast here address, we have 220.125.5.199. For the another one we have your subnetwork 2. For the subnetwork 2 here, that is your 220.125.5.200, 220.125.5.207, and the broadcast address (220.125.5.207). For the here, that is for the subnetwork 3, 220.125.5208 to 220.125.5.215. For the broadcast address, we have 220.125.5.215. Let's go ahead with subnetwork 4. That is 220.125.5216 to 220.125.5223 here. For the broadcast address, that we have here, that is your broadcast address, and then we have your broadcast address for that, that is your 220.125.5.223. Let's go ahead with the subnetwork 5, that we have 220.125.5, that is 224 2, and that is 220.125.5.331. The broadcast network, broadcast address we have, and for that we have broadcast address for subnetwork 5, that is 220.125.5.231. For the subnetwork 6, we have 220, and that is 0.125.5.232 2, and that is your here 220.125.5239. And for the same broadcast address for subnetwork 6, and that is we have here is your, that is 220.125.5.239. Let's go ahead with subnetwork 7 here. Subnetwork 7, in the subnetwork 7 we have 220 125.5.240 to 220.125.5247. And for the broadcast address, for the 7, that is 220.125.5.247. For the subnetwork 8, and that we have is your 220.125.5.248, 2220125, and then that is your 5.255. And for here, that the net broadcast address, that is you have 220.125.5.255. So let's go ahead to discuss IPv6 here. In the IPv6, the first question they can ask you, explain briefly that the new feature in the IPv6 as compared to the IPv4. What is the purpose of the multiple header? Explain and how IPv6 handles the multiple headers as well. So that has been asked of 10 marks as well. And now we have to discuss the new feature. So that is new feature, or that is in IPv6. So in the new features of IPv6, there are 6 features in new features that has been introduced. The first is that the larger address space. The second feature is that is better header format. The third we have is your security capability. The fourth we have is your support for resource allocation. Support for resource allocation. The fifth we have is your new option. And the sixth we have so with this we have the sixth one, that is your the allowances for extension. In this, that IPv6 addresses are of 128 bits in length, as I told you about, and the addresses that are assigned in the individual interfaces on the nodes that are not to be the node themselves, and a single interface that may have a multiple unicast addresses. And the first field of any IPv6 address is variable length format prefix, and which identifies the various categories of the addresses as well. For the purposes of multi-headers here, that the IPv4 header includes all the options, and therefore each intermediate router must check for the existence and the process them when present, and this can cause performance degradation in the forwarding of IPv6 packet. And with the IPv6 delivery and forwarding options that are moved to extensive header, and that only extension header that must be processed at each intermediate router in a hop by hop, and that option extension header as well. This increases IPv6 header processing speed and improves the forwarding process performances as well. In the same case, the extension header, multiple header we have. Extension headers, we can say that multiple headers as well. Here that the length of the base header is a fixed of 40 bytes here, and that is the type of the extension that headers we have is there are also the sixth one, that is the first is your hop by hop option. In the hop by hop option, that is used when the source needs to pass information to all the routers that is visited by the datagram. The second we have here is that is source routing. In the source routing, that extensions headers combine the concept of strict source route and that loose source route options for IPv4 as well. The third we have is your fragmentation. In the fragmentation, the concept of fragmentation is the same as that of IPv4. In IPv6, only the original source can fragment. The fourth we have is your authentication. In authentication, the authentication header has a dual purpose. It validates the message sender and ensures the integrity of the data. The fifth we have is that is encrypted security payload. Encrypted security payload. In this, that the encrypted security payload is an extension that provides the confidentiality and guards against that keys dropping as well. The sixth we have is your destination option. In the destination option, that the destination option is used when the source needs to pass information to the destination only, and the intermediate routers that are not permitted access to this information as well. Let's go ahead with another one, that we have your deficiencies in IPv4. So here we'll go ahead with the deficiencies of IPv4. In the deficiencies of IPv4, if I'm talking about, so here the first we have is your addressing space. In the addressing space, that the IPv4 addresses is of 32 bits, and which allows to allocate 2 key power 32 addresses. And IPv4 present two-level addressing hierarchy, that is the network number and the host number, and each network interface is identified with one or more unique addresses, and the two-level addressing hierarchy is convenient but wasteful of the addresses space as well. The second we have here is auto configuration and mobility. Auto configuration and mobility, where that is new technologies, that is mobile equipment, wireless network that are emerging, and its uses is quickly becoming common, and IPv4 did not foresee its use, and there is no automatic way of automatically configure this kind of equipment as well. The third we have here is your support for real-time application. So support for real-time application here, that the services such as the transmissions of real-time audio and a video that are becoming common nowadays. IPv4 does not provide for ways of managing and reserving bandwidth, which is a drawback to the user of real-time services with IPv4 here. In the same case, if I'm talking about with the next one, that is the fourth one, that is no security of the network here. No security at the network layer. So here in the case, and the fifth, we have growth of, that is your growth of the TCP IP usage. The growth of TCP and IP usage into the new areas, with the result in a rapid growth at a demand for the unique IP addresses as well. The sixth we have, that is your network are proliferating rapidly. So here now we'll discuss some of the short answers questions here. In the reference towards it, what is broadcast IP addresses? In the broadcast IP addresses, if I'm talking about here, that has been asked of 2 marks. That is your broadcast IP address. In the broadcast IP addresses here, that the spatial IP addresses used to transmit data packet to network, and a broadcast address is a logical address at which all the devices connected to the multiple access communication network and are enabled to receive the datagram, and a message sent to a broadcast address is typically received by a network that is attached host rather than by a specific host as well. For that same case, we have a question here, that is give the IP addresses of 180.25.21 172, and for that, and the subnet mode for this, and what is the subnet addresses we have. So let's go ahead to do that question that has been asked of 2 marks. That is, give the IP address 180.25.21.172 and subnet mask, that is 255.255.192.0. that is, what is subnet address? That has been asked of 2 marks. What is the subnet address here? So let's go ahead for this, and that is, we have an IP addresses here. So that is your 180.25.21.172, and the subnet mask we have, that is 255.255.192.0, and in the regard of it, that is the subnet address, that is your 180.25.0.0 here as well. What is the count to infinity problem here? That has also been asked of 2 marks here. Count to infinity. In the count to infinity here, that is, suppose that the link AB is broken, router B observed it, and but it is routing table is he sees that the router C has a route to A and with the 2 hops, and the problem is that B does not know that the C has a router B, and a successor hits a routing table on that route to A as well, and that followed to the count to infinity problem, and router B actualizes his routing table and then takes the router to A and overroute C here. So now we'll go ahead with the question, that is, what is the net mask of the gateway interfaces in the subnetwork where the maximum of 25 hosts exist, and the IP addresses, one of the host is 192.18 168.1.1. This has also been asked of 2 marks. So where the IP address of this is belongs to class C, and the default subnet we have 255.255.255.0, and the net mask we have here that is related, that is 255.255.255.224 here. So that is the net mask here, that is 224. And the same case, the defined routing, in what way the different from the switching, that has been also asked on 2 marks. So where you have to write it that routing is the process of selecting the paths in a network through which the network traffic is sent, and the routing is performed that is outside the network, and the internetworking switches is performed within the network as well. So state the duties of the network layer. The duties of the network layer, the first is that the responsibility of the source to destination delivery of packets, and the logical addressing, and of course the routing here. What is multicasting? So as I told you many times, the delivery of the information to a group of destinations simultaneously using the most efficient strategies to deliver the message over each link of the network only once. So that is known as multicasting. What are the different kinds of multicasting routing? That is, different kinds of multicasting routing are reverse path multicasting and reverse path broadcasting as well. We are to define subnetting. The subnetting is a technique that allows a network that administrator to divide the physical network into the smaller logical network, and thus control the flow of the traffic for the security or the efficiency reason. The next is that what is multicast, what are the motivations for developing the multicast here. In the same case, that the multicasting means delivering the same packet simultaneously to a group of clients, and motivations for delivering multicasting is that there are applications that they want to send a packet to more than one destination host as well. In the same case, what is address resolution? Address resolution is the process of obtaining the physical address of the computer that is based on its IP addresses, in order to be able to finally actually transmit the frame or a datagram over the network to which the node belongs. And what is the purpose of address resolution protocol? That is ARP. In the case that ARP is a dynamic mapping method that finds a physical address for a given logical address, that is the mapping addresses to physical addresses as well. In the same case, what is the benefit of DHCP? In the DHCP benefits the simplicity, mobility and mobility of the network. The simplicity stands for the client need no manual configuration. Mobility of the host is that host may move between networks without the reconfiguration here. And for the mobility that is of network, that is a possible for the internet service provider to reconfigure customers address transparency. That is note that however the renumbering kills existing TCP connections as well. That is, the fourth is the safe addresses space if individual clients are not always active. Now we'll discuss what is an IP addressing. An IP address is a numerical label assigned to each device in a computer network that uses the internet protocol for the communication. The two important functions of the IP address we have, that is the host identification and the location addresses here. That is addressing here. What is routing? Routing is the process of selecting paths in a network through which the network traffic is sent. Let's go ahead to discuss the principles of reliable flooding and its advantages and applications. So the principle is that making sure all the nodes that is participating in the routing protocol that get a copy to a list state information for all other nodes, and periodically send a linked state packet, that is LSPs, on the links, and they use explicit acknowledgement to retransmit the make flooding reliable, and each LSP with LSP that will travel at most once over the each link here. For the advantages, that is, it is the shortest path algorithm here. The second is that there is a guarantee of delivering of packets and simple to implement. These were the three advantages of that principles of reliable flooding, and here that is the advantages. And now the applications we have to discuss, that is used in the military applications, used to link state routing algorithm as well. With the same case, what are the silent features of IPv6 here? Here, that is, the silent features are that efficient and hierarchical addresses and routing infrastructure. IPv6 network provide auto configuration capabilities, that improved security feature, better support for the quality of services, large address space, and stateless and stateful address configuration as well. Now we'll go ahead with define BGP here. BGP stands for Border Gateway Protocol. That is your border gateway protocol here. That is a standardized exterior gateway protocol that is design, routing and reachability and information that is between the autonomous systems on the internet. Let's go ahead to discuss the metrics that is used for the routing protocol here. That is your traffic matrix, distance matrix, urgency matrix, services matrix and performance matrix as well. So here we'll end up with a network layer here, and that's what we have to even though discussed about it. And now we'll go ahead and we'll start with the unit 4, that is your transport layer here. In the terms of it, what we had discussed about it in the computer network, that we have completed unit 1, unit 2 and unit 3 here, and in the next coming classes we'll start with the transport layer and of course application layer in the next coming classes. The unit 1 is your introduction concept related to the computer network, that is we had completed the goals and applications of network and the network structure and architecture, the OSI reference model, the services, network topology design, delay analysis, backbone design, local access network design, physical layer transmission media, switching method, ISDN terminals handling. In the unit 2, medium access sublayer, that is medium access sublayer, the channel allocations, LAN protocol, Aloha protocol, overview of IEEE standards, FDDI, data link layer, elementary data link layer, sliding window protocol, error handling. In the unit 3, that is your network layer here, that is your network layer, that is point-to-point network, routing, congestions control, internetworking, TCP, IP packets, IP address, IPv6 as well. In the unit 4, we have to discuss transport layer, that is your transport layer, design issues, that is connection management, sessions layers, design issues, remote procedure call, presentation layer, design issues, data compression technique, cryptography, TCP windows management as well. With the unit 5th here, that is application layer, file manager, access and management, electronic mail, virtual terminal, other application, example network, internet and public network. That's what we have to cover up in the next coming classes. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thanks for all the subscribers, those who had subscribed to our channel. Thank you.